In this section, we will look at some practical ways to test a circuit if there is a problem. Understanding how to safely measure a circuit is of great importance in order to efficiently discover the cause of a malfunction without causing harm to the vehicle. For the purpose of this demonstration, the components used in the following scenes are not from the same vehicle that the wiring diagram was designed. Let us consider a problem where the horn is not functioning when the driver presses the horn switch. We already have a good understanding of how the circuit works, so by referencing the wiring schematic, we should be able to make a series of measurements to pinpoint the location of the fault. A quick and easy first step would be to inspect the fuse to see if it has failed. A burnt fuse could indicate a short in the system caused by an excessive amount of current flow in the circuit. If the fuse is not burnt, we should next test to see if voltage is present across the fuse location. Note that the diagram shows that the fuse is supplied by a hot at all times voltage supply. We are going to measure voltage at these two locations, here and here. With your multimeter set on voltage, place the black lead against a known good chassis ground. Now place the red lead on the conductor access point on one side of the fuse. You should read source voltage. Now place the red lead on the access point on the other side of the fuse. Again, you should read source voltage. If source voltage is not measured, we would need to investigate the vehicle's power distribution circuits to discover the cause. If no problem was found, continue testing downstream in the circuit. Because the system is designed in such a way that the generic electronic module can also control the activation of the horn, a helpful next step in our diagnosis would be to use a scan tool connected to the vehicle. The scan tool could command the generic electronic module to activate the horn. With the scan tool connected to the vehicle's diagnostic port, find the output control options for the horn relay. Command the horn to sound and observe what happens. If the horn does sound, it tells us quite a bit about what the problem may be. As we have successfully made the horn sound by activation through the control module, the relay and the entire high current load side of the circuit, including the horn, must be working as designed. The problem will be related to the low current control side of the circuit between terminal 3 of connector C270B and ground location G204. We would then need to test all of the conductors, the clock spring, and horn switch to find the cause of the problem. If the horn did not sound when commanded by the control module, we will need to do some other tests to further narrow down the issue. We will now test to see if the relay can be felt activating. Using your hand, place your fingers on the relay. Command the relay on using the scan tool. Listen and feel for the relay switch contacts activating. If you can hear the relay engaging when commanded by the scan tool, but the horn does not sound, try activating the relay again by pressing the horn switch. If you again hear or feel the relay engaging, we have confirmed that the entire low current control side of the circuit is functioning normally, so the problem must be located on the high current load side of the circuit. A quick way to safely test the high current load side of the circuit would be to install a fuse jumper across terminals 30 and 87 of the relay terminal sockets. This would effectively bypass the high current switch of the relay, jumpering voltage directly to the horn circuit. To safely perform this test, we will need to identify the correct relay terminal sockets. Note that the wiring schematic does not number the pin locations for the relay. With the relay removed, we can now see the terminal sockets that the relay plugs into. Again, note that the terminal sockets are not numbered. To ensure measurement at the correct locations, we will need to reference the pin terminal numbers on the relay body, as well as the wiring schematic printed on the relay. It is helpful to place the removed relay upside down beside the socket terminals for easy identification of the terminal socket locations. Because the relay is upside down, the number seen on the relay terminal locations will be a mirrored relationship to the terminal socket locations. For example, terminal 85 of the relay shown here mates with the terminal socket shown here. Relay terminal 86 mates with the terminal socket shown here. Terminal 87 matches this socket, and terminal 30 matches this socket. Once you have identified terminals 30 and 87, take one terminal of the fuse jumper and place it into terminal socket 87. Take the other terminal of the fuse jumper and place it into terminal socket 30. If the horn sounds when the jumper is placed across the terminal sockets, it would confirm that the circuit between terminal 8 of connector C270C and ground location G102, including the horn, is in good working order. It must mean that the high current electrical switch contacts inside the relay are faulty. Bench test the relay circuit contacts as described previously to confirm that this is indeed the problem. Then replace the relay. If the horn did not sound when the fuse jumper was placed across the terminal sockets 30 and 87, we would have to perform further measurements to confirm the source of the problem. Confirm that voltage is present at the relay's terminal socket number 30 using a voltmeter measuring here. Then test the rest of the high current load side of the circuit between terminal 8 of connector C270C and ground location G102. A failed conductor, horn, or ground in this portion of the circuit must be the source of the problem. Let's back up a bit and consider another scenario. We previously tested the relay to see if we could hear or feel its activation. Let's say that this time the relay is not heard or felt activating. We must then conclude that the problem is related to the low current control side of the relay circuit. Confirm that source voltage is reaching the relay at the inlet terminal socket here using a voltmeter. If no voltage is present, diagnose the fault between the terminal socket here and fuse 33 here. If voltage is present at the terminal socket here, bench test the relay as previously described to confirm that the electromagnetic coil is functioning properly. If not, replace the relay. If the relay bench test confirms that the relay is okay, continue your diagnosis for the cause of failure on the low current control side of the circuit. Diagnosing a fault in an electrical circuit can be challenging. Developing a diagnostic strategy to effectively solve a problem can only be done by first understanding how the circuit works. Safe and effective usage of diagnostic tools ensure time efficiency and reduces the chance of damaging the sensitive electronic circuits on the vehicle.